The question it's about commercials in the Super Bowl. We really need to focus our attention to is the last sentence. Do these data allow us to infer that the mean number of commercials watched is greater than 15? So if you look at the back of the book in Appendix A, it gives you the sample information. Sample mean is 15.27, so that's the average of those who watched commercials that they sampled, how many they watched. Sample standard deviation, 5.72. Sample size, the number of people they talked to is 116. Significance level is given at the beginning of the section that we're supposed to use, so 5% significance level. And what we're asking here, again, we're testing whether it's greater than 15. So our null hypothesis is that the mean is equal to 15. The alternative is that the population mean is greater than 15. And this tells me that we have A, a one-sided test to the right, and B, that we have that the hypothesized value of the population mean is 15. Okay, so now we'll do the rejection region. So I'll draw a quick picture of that. Again, the two pieces of information we need to know for the rejection region. Actually, I'll take a step back. We're having to use a t-distribution again. Remember, we don't know the population standard deviation. We just know the sample standard deviation. So that's why we're using this t-distribution. It looks like a normal distribution. Standard at 0. When I think about, well, what's the type of test we have? Here it's a one-tailed test to the right. So I know the rejection region is going to be out here to the right. We need to think about, well, what's the area out there in terms of the probability? We're told significance level is 5%. We're going to be at 5% out here. Okay, and so every piece of information we need is degrees of freedom. V is the sample size minus 1. Here sample size is 116. It's come out to 115. Again, this is an instance where it doesn't match up directly with the table. I'm just going to round this to 110. But again, on the exam, I'll be more clear about it should be clear what the degrees of freedom are. So what's this critical value here? Well, it's going to be a t with 0.05 right tail probability. Again, t-table, we're looking at the right tail probability. The 110 degrees of freedom. So if we mosey on over here to our table, if it's visible at all, you can see that the critical value is 1.659. Again, I'm using 110 degrees of freedom. Okay, so I want to put here 1.659 as that critical value, and this then implies that my rejection region is when my test statistic is greater than 1.659. Okay, so that's our rejection region. That's step 3. Our next step is to figure out our test statistic value, and that's going to be just a t-statistic, the formula sample mean minus the hypothesized mean divided by the sample standard deviation, and that then is divided by the square root of n. Okay, so just plug in those values here. We end up with 15.27, that's our sample mean, minus hypothesized mean of 15. Sample standard deviation is 5.72. And that's then divided by a square root of 116. Okay, so when you calculate this number out, it comes out to 0.5083. Okay, well, next then compare that to rejection region. It is not greater than 1.659, so our test statistic not in the rejection region. Therefore, we failed to reject the null. So we've got our thumbs up, thumbs down vote on the null. We're going to fail to reject because our test statistic does not follow the rejection region. Okay. That then leads to step 5, which is our p-value. Again, I would draw a picture of this. And when we have a p-value, what we would do is plug in the value that we found in our test statistic. Here, that's its distribution standard at 0. The tested value is 0.5083. Okay, so what are we trying to find? Given us a one-tailed test to the right, our p-value is over here to the right. And so our p-value is the probability that t with 110 degrees of freedom is greater than 0.5083. Okay. So the good news is that we can find that in the table. It's a right tail probability. So I go over to the table, look in the row for 110 degrees of freedom. I see that the smallest t-statistic value it's given is 1.289, which corresponds to 0.1. Given the table moves in the left to right fashion, that means that the p-value is going to be less than, it's going to be greater than 0.10. Okay, so I don't know anything more precise than that, but I do know that since on this side of the table, that this probability is then greater than 0.10. Okay, that's as precise as we can get. Again, the book may give a more precise answer to this because they're using a computer software. Okay, and then if we were to summarize this, our results would be that we were failed to reject the null hypothesis at a 5% significance level. And given that relatively large p-value, there's no evidence really against the null hypothesis.